Okay, this is going to be a short video. I want to talk about working with Kevlar cord. I sent you a lot of information in an email about the different glues, the different cords. There is a lot of stuff to think about. Kevlar is very nice for model rocketry. It's very strong, very light. Fire resistant, but it is not fire indestructible. If you put too much heat on it, it will begin to break apart. I did have this happen in a rocket where the ejection charge fired right at a Kevlar line. It was actually this width, and it just blew it into pieces. So we do have to take some degree of care in terms of how we use it. One thing about Kevlar is that it's almost completely chemically inert. It doesn't react with anything. As such, it's really hard to glue it to anything because it just doesn't want to, glue doesn't want to stick to something that it doesn't react with. So we have to do some work in terms of how we're going to work with the Kevlar. The two types of Kevlar that I have is the 100-pound. This particular Kevlar cord is, this cord is 0.8 of 1 millimeter. It's really thin. It's almost like dental floss. I use this in the very small rockets like the Gnome and the small high flyer rocket. Again, it's 0.8 of 1 millimeter. So I use it in those rockets, and I'm currently building, actually, I'll show you that here. Okay, let's get the camera realigned here. Okay, so I'm rebuilding an Honest John, and you can see I use this 100-pound Kevlar in here, and it works just fine. I don't use swivels on the very small rockets because they're too heavy and there's not enough room. Okay, so getting back to reality on Kevlar. Kevlar does wick the CA glue, namely it will let this soak into it. So Kevlar glue is very good for soaking in. I do use this glue, the Gorilla Glue. It's sort of like the thin glue that is sold by Apogee, but it's just a little bit thicker. I get it because it's just simply quick to go to the store and get some that's like $5 or something like that. So I use the thin glue for working with Kevlar. And let's go through how we're going to work with this. There's a technique that Dave Thomas showed me, and I do believe this is a very important technique. It solves the problem of fraying, and let's go ahead and just cut the end of the cord off. So as we cut it off, you can see the cord is already starting to fray. The end of it's all pushed out, bulging, so this is starting to fray already. Now the problem is that if you tie a knot, it's going to unwind itself because the fray part is going to move all the way to the knot. It's going to hit the knot, and then it's going to go inside the knot, and eventually your knot pops apart. And again, inside of the rocket body, we're not going to get a chance to fix these things. So we've got to make sure that we take precautions to make sure that this is taken care of. I'm going to do something, again, that Dave Thomas showed in his video. He called it touching the Kevlar. I don't know if there's any other real word for this. The idea is we want to put a very small drop of the Kevlar glue on the end here. And then we're going to squeeze it with this paper towel. Now what's interesting is that if you squeeze it with the paper towel, it instantly hardens the glue. And that's really strange. I'm not exactly sure what chemistry happens there, but it works. And let's go ahead and show you. You can see how this end is all frayed and difficult to tie with. So let's just put a very tiny, I usually put a very small drop on, just kind of rotate it around, rub it in. And now the Kevlar has wicked in. But now what we do is we just simply take the paper towel, wrap it around it, and pull. And now you can see slight stickiness, but now it's nice and hard. And what's nice about this is now we can tie it, and we don't have to worry about it fraying and unwinding into the knot. So again, this is the very end, about maybe 1/8 of an inch that we have treated. And if you want, you can cut that off. Now it's nice and stiff, and it won't fray anymore as you cut into the glue area. And again, the way that a CA glue works is that the cyanoacrylate is actually almost like a liquid plastic. When it gets exposed to moisture, it will convert the liquid into a solid plastic. And the whole idea is that it's triggered through the hydrogen ions in the water. I have the feeling that the paper towel collects a lot of moisture or hydrogen ions maybe, and when you hit that glue like this, it just boop, instantly hardens it. So again, like I said, it hardened instantly. It's a very, very nice thing to do. So we're going to be doing this, and I will often comment, I'm going to touch the end with glue. And what all I'm doing is I'm basically putting a small drop and then squeezing it to make it nice and tight so it doesn't start fraying. We do a lot with knots, and if you notice the way that I designed the recovery system, everything is put together with knots. And the reason is this way you can tie things together, you can untie things. If you want to change the nose cone, change the blanket, change the cord, you can just untie it, put a new one in and tie it back together. You've got complete flexibility in how you want it to work and any types of experiments that you might want to do. Okay, so that's it for my quickie on Kevlar, and you'll be seeing, we'll be using all this, this black 300-pound Kevlar for our Black Brant project. Okay, have fun.